Hello everyone and welcome to the channel. Mistral AI has released the research behind their vision model Pixtral 12 billion. In this video, we are going to have a look at the salient features and nuggets from this paper because it is always good idea to know behind the scene what is happening in these vision and text models. So let's get started. First and foremost, this Pixtral model, we have covered it a lot on the channel, so if you're interested in knowing it in action, how exactly to install it locally, and then how to generate images, and also how to do OCR and a lot of other stuff including API, please search the channel with Pixtral and you should be able to find heaps of videos on it. Coming back to this model, Mistral came up with this 12 billion parameter language model that excels in understanding both natural images and documents. This open source model achieves top performance on various multimodal benchmarks and has outperformed larger models like Llama 3.2 90 billion, while 7 times smaller. Also, this has been trained from scratch with a new vision encoder that allows flexible image processing at native resolution and aspect ratio. It processes up to 128K tokens in its context window, enabling multi-image and multi-turn conversation. It delivers strong multimodal reasoning without compromising text-only performance. One thing I have noticed that this paper is riddled with benchmarking information. I think there is too much benchmarking information and evaluation matrices, and they have shown that it has outperformed various other models like Qwen2, Vision Language 7 billion, 3.2 Llama on MMMU and Math Vista and few other things. So I think you can read through in the paper and I will drop the link to it in video's description. Let's have a quick look at its architecture. Before we do that, let me give a huge thanks to AgentQL who are sponsoring this video. AgentQL is a query language for extracting data from web pages quickly, easily, and at scale. You can use the Python SDK to run your queries in production using Playwright and use the browser-based debugger for optimizing queries in real time on any web page. AgentQL is a robust alternative to fragile XPath and DOM CSS selectors as it uses the power of AI to analyze the page structure to find the data you are looking for. Let's go to its architecture and check it out. So if you look at this diagram, this is Pixtral's vision encoder. Pixtral uses a new vision encoder which is trained from scratch to natively support variable image sizes and aspect ratios. Block diagonal attention mask enable sequence packing for patching, while rope 2D encoding facilitate variable image sizes. You can also note that the attention mask and position encodings are fed to the vision transformer as additional input and utilized only in the self-attention layer, which is quite interesting. Similarly, if you look at this diagram, this tells you the complete Pixtral architecture where the Pixtral has two components, a vision encoder which tokenizes images and a multimodal decoder that predicts the next text token given a sequence of text and images. Pixtral can take an arbitrary number of images as input provided they fit within its 128K context window. Pixtral 12 billion is based on transformer architecture and consists of this decoder to perform high-level reasoning and a vision encoder to allow the model to ingest images. The main parameters of the model are uh, listed in this image as you can see. Pixtral 12 billion is built on top of Mistral Nemo 12 billion, which is a 12 billion parameter decoder only language model that achieves strong performance across a range of knowledge and reasoning tasks. Vision encoder is quite interesting. In order for Pixtral 12 billion to ingest images, they have trained a new vision encoder from scratch, which is called as Pixtral VIT or Vision Transformer. Here, their goal is to instantiate a simple architecture which is capable of processing images across a wide range of resolutions and aspect ratios. To do this, they have built a 400 million parameter vision transformer and they have made 4 key changes over the standard architectures. That includes break tokens, gating in FFN or the feed forward layer, sequence packing, and rope to 2D. For me, Rope 2D is the most interesting one as it has replaced the traditional learned and absolute position embedding for image patches with relative rotary position encodings in self-attention layers. While learned position embeddings must be interpolated to deal with new image sizes, relative position encodings lend themselves naturally to variable image sizes, and that is why the quality of images in this model is quite natural. So if you see here, they have also open sourced a new instruction following benchmarks, which is called as MMMT bench for multimodal models, which correlates highly with LM sys elo ratings. So here, if you look, given an input image, reference answer and model response, an independent LLM judge is instructed to grade the model's response on a scale of 1 through 10. How interesting is that? Similarly, in this image, you can see the effect of naive versus explicit prompts on leading models. Leading models benefit greatly from explicit prompts, which provide details about the output format. This makes sense, otherwise, substantively correct responses are marked as incorrect during evaluation, and that is what that Rope 2D is doing, as I mentioned earlier. So, all in all, seems like a real good stuff. And also, we all know that this Pixtrol 12 billion has been released under Apache 2 license that provides a cutting edge open source solution for multimodal language understanding. So this was a short, quick introduction to this Pixtrol model. Let me know if you have tried it out, and if you have something else to share in the comments. Really keen to know about the experiences of the people with it, because when it was released there was a lot of I would say hype around it, but I think with the advent of other vision models like Quen's vision model, and there are heaps of other, I think this has just gone into the back burner. But still, I believe that it is quite a good state of the art multimodal model that excels in both text only and multimodal tasks, especially its new architecture with 400 parameter vision encoder and 12 billion parameter multimodal decoder. This has demonstrated strong performance across various benchmarks, and we also tested it out, and we saw that not only its support for variable image sizes but also the long context window made it highly versatile for complex multimodal applications. So that's it, guys. I hope that you enjoyed it. Let me know what do you think. If you like the content, please consider subscribing to the channel, as that helps a lot. And if you're already subscribed, then not only please share this video but also the other Pixtrol video and the whole channel. Please share it among your network on the social media, as I will be very grateful for that. Thank you for all the support, and thank you for watching.